Assalamu alaikum wa rahmatullah. This is teacher Momen from Al-Hijazya school, and this session for grade 6, it's about math and science. It's I think it's lesson 3. Yes, it's lesson 3 from math and science. Lesson 2, I'm sorry, it's about math and science. We have two goals in this lesson. First one, what math skills do scientists use? And the second goal is, what math tools do scientists use? Okay, first, let's go back to our textbook here. Everyone, if you open your textbook page 81, you will find the first definition that is very important in our lesson. So it's about estimate. Estimate is an approximation of a number of based on reasonable assumption. And estimate is not a guess. This point is very important, that estimate is not a guess. It's always based on known information. For example, if I know the prices for Toyota Camry cars, for example, its ranges for models of 2010, it ranges from 15,000 to 16,000 reals. So I can estimate or guess, or not guessing, I can estimate. Why estimate? Because I have a background information about the car prices, so I can estimate. Estimate means give right range from to, but the right or exact number or exact price is between from to. Okay, this is what is the meaning of estimate. Okay, so the most important point in this definition is, an estimate is not a guess, it's always based on known information. And from here we will start to study the difference about, or the difference between accuracy and precision. طيب. Accuracy and precision, as definition, accuracy refers to how close measurements to the true value. Precision, how close the group of measurements to each other. Here, accuracy is about how close to measurement to the true value. If I made 4 5 tries in the lab, okay, and my measurements was about to measure the gravity, okay, if I have any measurement that's close to the true value, I can call it its accurate measurement. Okay, if my measurement is close to the true value, it's called what? Accurate measurement. Okay, now this is about accuracy. Precision, how do close the group of measurements to each other. Precision, if you look at here, we have one, two, three, four figures. First one, we have low accuracy, low precision. Why? Because the measurements are, they're away from each other, and they are not close to the what, to the true value, which is the target. Here, low accuracy and high precision. Now, low accuracy, because the measurements are not on the target, or at least close to the target, but they are grouped outside the target or away from the true value. So we have high precision because the measurements are grouped out or away from the true value. So we have here low accuracy, high precision. In this figure, we have high accuracy, low precision. Why high accuracy? High accuracy because the measurements are close to the true value. Close, not exact, has the magnitude of the true value, but they are close to the true value. But low precision here because the measurements are not grouped together like here and here. In this figure here, in this part here, we have high accuracy, high precision. Why? Because the measurements are close to each other or are grouped on the what, on the target. So here again we have low accuracy, low precision, and we said why. Here we have low accuracy, high precision, low accuracy, low precision here, high accuracy, low precision, and here we have high accuracy, high precision. Okay, I hope everyone will read the definitions and understand the definitions before studying these figures. طيب. Now let's go to talk about, after knowing the difference between accuracy and precision, we have to talk about significant figures. Significant figures, in summary, it means the important figures. It means important figures or important numbers. Important numbers that can change the measurement, that can give the measurement its true value. If you add zero point 0.1 or if you subtract zero point 0.1, it can change the measurement from true value to what? To not true value. Okay. And this figure or this number that we add or subtract called what? Significant figure. So let's get started with significant figure by how could we add or subtract measurements. Adding or subtracting measurements. Here I put here an example about addition and subtraction with significant figures. When we add or subtract measurements with significant figures, the result has the same number of decimal places, has the same number of decimal places as the measurement with the fewest. Again, with the fewest number of decimal places. How? Let's see here. We have 5.74 plus 0.823 plus 2.651. How many decimals here? We have one, two decimals. Why? Because these two numbers located before the decimal, yani at your right hand side. Here we have one, two, three decimals plus we have here one, two, three decimals. Which one of these numbers has the lowest decimals? This one, because it has two compared with this one which has three and this one which has also three numbers. So if you add them using your calculator, you will get this number 9.214. But this is not a significant figure that or this is not the answer which depends on the significant figure rule. So the answer should contain only two decimals. So this is not the true answer. This is the true answer. This contains two decimals. Why? Because the least decimal here, decimal, is 2. Okay, we have two decimals, 3, 3. The answer should not contain three decimals. So it should contain two decimal or two decimal number or decimal places. Okay. The same thing here in subtraction. So the rule can be applied on addition and subtraction. 4.8 minus 3.965 equals 0.835. So this is not the true value. Okay, the true value is zero point 0.8. Why only zero point 0.8 and we round this number to 8? Because we have the least decimal places here is 1 compared with this. This has three decimal places, and we have here only one decimal place. So the answer should contain only one decimal place. If you use your calculator, you will get this answer, and this is not true using significant figures rules. So this is the true value, which is contain only one decimal. This is about addition and subtraction with significant figures. Okay, so let's continue our topic. Now let's go to talk about multiplying measurements. Now multiplying measurements, it depends on what? On the significant figures, not on decimals or decimal places. In addition and subtraction, we use decimal places rule, but in rule of for multiplication and division, we use what? We use significant digits or the significant figures or significant numbers rule. طيب. For multiplication and division, your answer must show the same number of significant digits or significant figures or significant numbers as the measurement in the calculation with the least number of the significant digits. How? Here we have one, two, three, four, five significant figures, but here we have one, two significant figures. So if you multiply them using your calculator, you will get this answer. But your answer should has only two significant figures. Because why? Because here the number 1.6 has two significant figures. Here the number 2.8723 has five significant figures. So the answer should have what? Two significant figures. So we should round 9 to what? To 6 to get what? Only two significant figures. Again, if you multiply these two numbers using your calculator, you will get this answer. And this answer using significant figures rule is not true. The true is you have to round 5.56 to what? To 59 or 59 to what? To 6 to get what? To get two significant figures. Now, what is the difference here between significant figures and decimal places? In 1.6 here, okay, and I'm telling this difference to not make you misunderstand between addition, subtraction, and multiplication. Here in this number 1.6, we have two significant figures. And how many decimal place? One decimal place, because we have only one number before decimal. Here we have five significant figures. How many decimal place? One, two, three, four decimal places. Okay. So in multiplication rule, we use significant figures, not decimal places. This point is very important. طيب. Let's talk about the math tools and science tools. So we've finished with adding, subtracting measurements, multiplying measurements. Okay. What math tools do scientists use? Now, the math tools, we have many math tools that the scientist can use: defining mean, or first calculating percent error. This is number one. Finding mean, median, mode, and range. So I think all of you studied this in the mathematics subject. Okay, so let's talk about first percent error. Now, percent error in definition is the calculations are a way to determine how accurate an experimental value is. A low percent error, يعني for example, okay, let's continue. A low percent error means that the result you obtained was accurate. The low percent means result is accurate. A high percent error means that your result was not accurate. Now let's give you an example. In measurement, in some measurement, you get a percent error of 1% compared with your friend who has a percent error of 5%. Which one of you are more accurate than the other? The one who has what low percent error. So let's learn, or let's talk about how can we calculate percent error. Now, the law of percent error here, percent error difference between experimental value and true value. Experimental value, the value that you got it experimentally, and the true value. Here, the experiment density of copper is, this is can be get theoretically, okay. The value, the true value is 8.9 8.92 gram per centimeter cube. Now the question is calculate the percent error. The percent error, you have to subtract them from each other. So 9 point or 9.37 minus 8.92 divided by the true value, which is 8.92 gram. So the true value, or the experimental value is the fixed value, and the true value, the value that you get using what, using lab tools. طيب, we will see another example about this. After you subtract them from each other and divide the answer to divided it by 8.92 and multiply the whole the whole process with 100%, you will get 5.04%. And this is what, this is the percent error that you get from using this mathematical formula. طيب, I think you can do this question or do the math by your own and show me your answer. Okay. Now, here we have another example about percent error. What is the percent error if the length of a wire is 4.25? If if the correct value, the true value is 4.08. Now, what is the percent error if the length of the wire is? Now, you have to subtract them from each other and divide them by what? By the correct value or true value. Correct value here also means true value. You will get what the answer. But here, the one who did the process has one mistake. The answer should not include minus sign. Okay, so the answer is 4.2%. Okay, the absolute value of subtraction between 4.08 and 4.25 divided by 4.08, you will get times them by 100, you will get 4.2%. So the most important thing here is to determine, or you have to differentiate between experimental value and true value. Again, experimental value, the value that can be existed in the lab, okay, and the true value, the value that you get using your lab tools. طيب. Now let's talk about the four math tools, remaining math tools. Four remaining math tools is mean, median, mode, and range. Now I will explain them using what? Using this figure or this schedule. Now this schedule is about the number of sea turtle eggs in seven nests. So we mark each nest with alphabet A, B, C, D, E, F, G, and the number of eggs in each nest. Nest number A or nest A has 110 eggs, 102 eggs in B, 94, 110 in D, E it contains 107, F contains 110, G contains 109 eggs. Okay, now let's talk about the mean. The mean is the numerical average of a set of data. To find the mean, add add up the numbers in the data set, then divide the sum by the total number of items you added. Here, if you go back to the schedule, the mean can be calculated by adding all this value to each other. يعني, let's do them using calculator. So 110 plus 102 plus 94 plus 110 plus 107 plus 110 and finally 109 divided by how many? 1, 2, 3, 4, 5, 6, 7 divided by 7. The average is 106. So again, the mean is the average, a numerical average of set of data. So what does that mean? You have to add them to add them mathematically, okay, and divide by 7. Why 7? Because how many nests do we have? We have 7 nests. طيب. Now let's talk about the median. The median is the middle number in a set of data. The middle number in the set of data. Where is the middle number set of data here? Now the middle number 1, 2, we have the middle number set to find the median. List all the number in order from least to greatest. From least to greatest. So we have 110, 110, 110. So I think it will be 107. I think it will be 107 because if we put them in order, this all number in order from least to greatest, the median is the middle entry. If a list has an even number of entries, add two middle numbers together and divide by 2 to find what the median. You will understand this by what? By doing calculations, and I will give you questions to do them by your own, okay, and you will send me the answer to correct them and to inform you where is your mistakes or how could you do this and do that. Okay, mode. The mode is the number that appears most often in a list of numbers. Now, what is the number that appears most often here? Is the 110, 110, 110. So how many times? One, two, three times compared with the others, which each one only appears once. Okay, so 110 appears three times compared with the other, so the mode is 110. The range here, the range, you have to subtract the highest value from the lowest value. The highest value here is 110 and lowest value is 94, so the range is 16. Okay, why? Because 110 minus 24 equals 1 equals what? Equals 16. Okay, So this is all about the math tools in science, and let's go to talk about the graph in science. So the graph in science, what all you have to know here is how could you how could you determine the points from the graph. يعني for example, or let's first see the definition of the graph. The graph is a picture of your data. One kind of graph is a line graph. Line graphs display data that show how one variable, the responding variable, changes in response to another variable, the manipulated variable. يعني in the Cartesian coordinate we have x and y, x axis and y axis. طيب, now this called linear graph. Why linear graph? It's a linear or linear line. طيب, uh, and the graph is about boiling time of water by volume. Boiling time of water in minute by volume in what? In uh, volume of water in what? In the unit of milliliter. طيب, in a volume, the volume of 500 milliliter of water needs about 9 minutes to be boiled. Okay, 9 minutes to be boiled. Here, 100 or 1000 milliliter needs approximately 16 minutes to be what? To be boiled using water. يعني you have to put the 1000 milliliter on fire for about 16 minutes to what? To start boiling. طيب, for 1500 milliliter, 25 about يعني approximately 25 minutes. طيب, 2000 milliliter, 33 33 minutes. So here what we can find here is the if we increase the number, or if we increase the size of water or the volume of water, then the boiling time will increase too. So from the science graphs, you can determine the relationship between two variables. Now here I determined the relationship between the two variables is when the volume of water increase, so the boiling time will be increased too. طيب, we have two kinds or two types of graphs: linear graph and nonlinear graph. Linear graph, as you can see here, average number of baskets made or distance from hoop. Now, this also linear number like previous one that we solved with each other in the previous page is also a linear graph. But this graph, the relationship between average number of baskets made and the distance from hoop is when the distance of hoop decrease increase, I'm sorry, the average number of baskets made will be decreased. يعني if the distance is 1 meter, the average number of baskets made is 5. If the distance is 2, the average 4 is 3. If the distance 3, the average is 3. Okay, the average number. If the distance were 4, the average is 2. So this is the relationship between the average number of baskets made and distance from the hoop. Here, the nonlinear graph, it's about population growth. Population growth can be done by nonlinear graph. So bacteria cells, population growth for human, for bacteria, for animals, for anything, it can be done using what? Using linear. it can be done using what? Using non-linear graph. Here, for example, randomly, if I take point 120, which is time in minutes, 120 minutes, the number of bacteria cells that will grow or that grow is 61 bacterial cells. And if I take 20, so it's about one or two bacterial cells will be grown. Okay, so this is what do we mean by linear and nonlinear graph. What I want from you here is to know how to read the data from the graph. يعني you have to see the x-axis and y-axis to see x-axis indicates, for example, here time, y-axis indicates bacterial cells, and I'm going to ask you about in for example in time 120 how many bacterial cells do we have according to the graph. Okay, that all what I want from you here in this lesson. So I hope everyone in a good health and see you next time. And our next lesson is models as tools in science. So see you next time, inshallah. And thank you for watching.